It's going to be a bit of fun. Lovely. Excellent. So we have our coil with our tapping points, and then what we'll do, we'll connect it to the SO239. The black cable will go into the center core, the purple cable will go to the shield, okay, and then it will go right to the other end where the purple cable will go to the shield and the white cable will go to the center core. Okay, and we've got two clips. One of the clips will go into a tap point, the other clip will go onto the capacitor which we've yet to build, and that will go on to the capacitor which we're yet to build. Anyway, let's solder it up so that we can move on to the next bit. And so to the capacitor kit. Now I purchased mine from online, from Etsy, from the SnowistCorner, who's the seller. And this kit is really, really beautifully made. I put mine together as a motor-driven version, and it has a capacitance of around 92 to 100 picofarads max, as you can see here. Okay, so let's quickly go through what we've got. SO239, center core fed straight to the coil. Coil's tapped, right, and basically we then got the white crocodile clip going straight to the center core of the exiting SO239, so it's straight through. We have our purple earth cable connected to the our purple shield cable, earth cable, chassis cable, call it what you will, going from the outside of the SO239 all the way to the outside of the other SO239. It's then looped back, okay, to one side of our capacitor. The center core of our exiting SO239 is connected to the other side of our variable capacitor. This is a kit. I've finished building this, but this is a motor drive version. As you saw earlier, the kit is a really nicely produced piece of equipment, from Epsy, from SnowistCorner. Anyway, so here we are. This one's actually going to be driven. It might be a bit OTT for our coil, but it proves hopefully our point. So TX this side, antenna that side, and we'll see if we can make it all work. Okay, let's just quickly go up through the band, and we know that about 280, 285-ish, I don't think there's anybody there, we've got an SWR of absolutely nothing. Okay, absolutely nothing. And that's with the capacitor set to where it is now, and the SWR is a zilch. Okay, but we want to operate slightly off band, so let's wang it down to the CWN. Let's go down to, I don't know, see if there's anybody there. We don't want to tread on anybody's toes. Just have a quick, no, nice and quiet. And the SWR there is, oh, it's quite high. So here we go. So this is where our capacitor and coil and our L network starts working. So let's start collapsing our capacitor. Like I said, this is only 100 picofarads, so we need to go quite a bit in, but it, it proves a point. That's about 3/4 of the way, and now we have an SWR of, oh, look, it's actually quite good. So let's see if we go a bit more. Might get it to 0, you never know. Yep, there we are. So we now prove that the network works, right? We can get the SWR down by using the tuning circuit, and in this particular case we needed to add more capacitance to get the lower frequencies in, and remove the capacitance to get the higher frequencies in. Okay, so we can see that our L network circuit works incredibly well. So the next thing we need to do is connect an SWR meter in front of it, one behind it, and perhaps even one at the base of the antenna. Each of them would need to have a watt meter on, so that we can actually see what power is reaching the antenna, if it increases, decreases, etc., so on and so forth. I think the best way of doing this is to use a commercial antenna matching unit, and for this I think I'll use my Polestar 1500 CV. This will give us a more accurate and repeatable result. So let's do that now. Okay, so let me show you the setup. This is the Yaesu FTDX10, and that is connected to the SWR meter on the right hand side. This one, the Power Master, which is then connected to the Polestar. The Polestar is then connected to the Zagi SWR stroke watt meter, and that is connected straight into the back of the antenna, obviously via some coax. Okay, now we are at 14.003 megahertz, and the reason for that is that I have a 0, or at least a 1-to-1 SWR, okay, with the antenna. So let's just key up and show you that. Okay, there you go. Let me just turn the Zagi SWR meter to reflected, rather than where it is now, which is on wattage. So here we go. So as you can see, SWR from the antenna is 1-to-1, SWR to the back of the rig is 1-to-1, and the SWR in the Polestar is 1-to-1. Okay, as you can see, they all just move gently. Not a lot in it. Okay, so there's our reference point. And on 20 watts, the Power meter is showing 1718 on the Power Master. On the Pulsar it's showing yeah, roughly the same, 1718. And if we need to turn this to our meter scale, one more, sorry about this. So it's now on the 25 watt meter scale, which strangely enough is the bottom one of the top arc, and that should, yep, okay, so that's roughly top 120. Okay, take a 0 off the top scale, so that's 20 watts. Okay, which is what this one's putting out, just to prove the point. 20 watts, okay. And the SWR on the rig is exactly the same, right? 1 to 1. So the next thing to do now is to wang it up to the top of the 20 meter band. So let's do that. Oh dear. A bit too fast there. So we'll put it at 347 if no one's there. 346.5. I don't know, it doesn't make a difference, does it? 346. I don't think anybody's there. Let's have a quick listen. Nobody there, right. So let's see what the SWR is now. 2.2, 2.3. Have a look on the SWRs up here. 2.2, 2.3, yep. 2.2, 2.3, but agree with it all the way around. How many watts are we putting out to the antenna with this SWR? It's about the same. It's about the same. It's about, oh, it's dropped on this one, so it's telling me that we're losing about 3 watts. So let's turn our tuner and tune this antenna in now. Should be a bit of fun. I don't think I've done this. Yeah, okay. Bear with me. Where can I put this so that you can see it tuning? I suppose I could just do it with we're transmitting. Right. Okay, so the SWR back to the wattage is still 20 watts. Let's turn that to the SWR, to the reflected. So that's on reflected, isn't it? Yes, it is. So our SWR is over 2. Still on the antenna, obviously. The tuner is telling us we've got a 1 to 1, and the ATU is telling us 1 to 1. And our rig is telling us 1 to 1. And we just take it off and transmit a minute. Let's check the output power, 20. So let's see what the meter's telling us. 20, 17. That's the SWR. Let's put it onto meterage. Sorry, I haven't got enough hands. $20, so it's slightly higher. Look at that, it is slightly higher. On the antenna. Okay, so we're going to go down to 28 megahertz, 28.45 meg, and we're going to be using, let's have a look, 15 watts, I think that is. Can you see that? 15 watts. Oh, there's someone on the frequency. Let's move away. SWR 3, SWR 4 point something, SWR, there we go, 3. So SWR is 3, this one says 4, this one says, look at the cross points, 3, and the radio says 3. So not a very healthy place. 15 watts, putting out 9, putting out 10, and let's have a look on the scale. So we're looking at the bottom one here, okay, and we're putting out 5 or 6 to the antenna, okay, according to that. Right, let's tune it, which I've already done. SWR 0, wattage out 11. SWR 0, wattage out 11. SWR is nearly 3. Let's see how many watts it's going to put out. 25 watt scale. So we're looking at the line, and we're putting 10 watts. So it's all as it should be. So the radio is happier, so it's now putting out 12 watts or 11 watts. Happy days. Okay, let's have a look if we take the tuner out of play. SWR is back up to 3, wattage is down to 9, and its output is 5.5 watts. Turn that back up to the tuned. 11 watts, 11 watts, 11 watts. So conclusions. What time is it now? It's goodness. Okay, it's 9:45 in the evening of a night time. I've been playing with this since 9 o'clock this morning, so it's been a long day playing around with it, doing various experiments. You've not seen all of them, believe you me. You've seen some highlights, if you like. So the conclusions. Right, the conclusion is a simplistic one, really. The ATU obviously transfers or transforms the high impedance down to the impedance that the transmitter wants to see, which means the transmitter is happy to put out its full wattage. That then gets transmitted to the antenna. You still get losses over the line between the back of the ATU and the base of the antenna. You're still getting the reflection back from the antenna to the ATU. Some of that power is going to ground, and then some of it is being reflected back up the line to the antenna again. And I think it's an ever increasing or decreasing flow of electrons going to and from. And that's where it's all being dispersed. I think this is why we saw a little increase in the power output compared to what was going into the ATU on the 40 meter band. That may have been an instrumental error. I'm not sure. But yeah, okay. We'll take it as read that matching the impedance from the back of the antenna to the transmitter makes the transmitter happy, therefore it puts more watts out and more power gets to the antenna in the end. You still get some back, but you're still having more going to it. So yeah, okay, you lose some in heat, you lose some to ground, and you also then obviously lose some of the power going back to the antenna, and it's an ever increasing just goes around and around forever. Okay, I hope that was of some help. It certainly answered some of my questions. It's opened up and asked me many more. yeah, it was a bit of fun to doing. So I hope you enjoyed watching the videos. If you did, please give me a thumbs up and please subscribe. I've reached the magic 10,000, so I'm very, very happy with that, and it's good to see. The feedback has been great, and it also obviously boosts my my confidence, so I make some more videos for you guys to watch. Thanks very much indeed. You have a good day. Cheers. Bye bye.